in the middle of moving house at the moment, so I've had a ton of problems, and as you can see, it is just me at the moment. I'm just trying to get the comments up. If you can bear with me one moment. Just trying to bring it up. I'm not sure if I can get it working today, so I might move that off and I will see if I can bring up the comments on Facebook instead. Okay, I've got the comments up on Facebook. If you want to comment there, if you're watching on YouTube or Twitch, I'm just going to have to leave it for this week, unfortunately. So since Lucy's away, I'd really like to do a science question and answer. So if you have any science questions for the past week, or you want to talk about the vaccine, anything like that, just let me know, and we'll go backwards and forwards, because I don't have a co-host this week. Unfortunately, Lucy's got some family business, so she's away up in Queensland and can't actually make it even by video tonight. If you have a science question, please whack it in the Facebook chat. At the bottom of this screen, you should be able to write a comment. Just send that through and I am happy to answer it. Things I love talking about are astrobiology and genetics. I like biology in general. So I've been building a lot of fish tanks lately, which is interesting because it's about creating sealed ecosystems, which is probably my favorite thing. In the meantime, I'm going to try and bring up I'm going to try and bring up the comments if I can. Normally there's a window on this side that displays the live comments, but I can't actually bring it up this week, which is... Let's have a look. Sorry, please bear with me. If you want to chuck any questions you have in, I'm just going to... no idea how to do this. Normally it just pops up when I link to Restream, but it hasn't this week. So here we go, chat. Is this going to work? It is. There we go, I've got the chat. Okay, bear with me just one moment. I just have to, one sec. Okay, I have worked out how to get the comments up. Please bear with me for 1 second while I get this one done. Okay. It's always a bit of an on-the-fly thing. So I'm actually, for any of those who've just tuned in, I'm moving house at the moment, and that's why we've got such a all over the place live stream. Actually, it's like this every week. Oh, thank you, Stephen. Is there a tidal effect on the atmosphere? There should be a tidal effect on the atmosphere, Sam. Basically, there is a tidal effect anywhere where there's mass. So the thing about the tidal effect on the atmosphere is it's going to be almost nothing because of the amount of mass. Like if I hold this mouse, this has a tidal effect on Saturn, but it's insignificant. The tidal effect of Saturn on it is much more than this on Saturn, and it's so far apart that it's basically negligible. But anything with mass is going to have a tidal effect on something else. The atmosphere has almost zero mass, so it's going to have a very, very small effect. It's going to have, so basically it will be pulled a little bit. The biggest effects on the atmosphere are generally caused by the solar wind, which is blowing out from the sun. Now, as I just said that that atmosphere doesn't really have much mass, but actually most of the mass in the solar system is in atmospheres. So it's in Saturn, Jupiter, mainly Jupiter, but 98% of the mass in the solar system is in the sun, and that's all just hydrogen and helium, and that actually has a huge tidal effect. And we could think about the plasma around the sun as being a form of atmosphere because it's essentially gas. So it's ionized plasma. It's like but it behaves, from my limited biological understanding, like a gas. I'm just trying to quickly get... Oh, I'm doing a Google capture at the moment, but it's very... I can't actually see. There we go. Okay. I've managed... I am not a robot. Okay, if... Yeah, a glass... That's right, Eden. A glass of water will technically have a tide. Could someone please just chuck a couple of messages in? I just want to see if the... just give me 1 second. Embed in stream. Okay, I've worked out how to put the chat in. Okay, I'm gonna add window capture. Window capture. Okay, and success. We have that chat window back up. Hopefully, if hopefully your chat messages will go in here now. Get a big shout out to Jun, one of my friends over in Japan. Thank you for watching the stream. I'm excited to find out about what you've been up to. Please chuck any science questions you have in. Stephen says, I can hear you. Eden says, okay, there we go. It's coming through now. Okay, there's a little bit of a delay, as you'll see. A bathtub has visible high tide and low tides. That would be really interesting to see. I would be really interested to see whether that's true. Now, one of my friends actually said that there was an argument for moon planting. Is that very, very long trees might actually have tidal effects, pull the water up to the top of them, so trees might grow more on a full moon. I don't know if that's true. I don't think it is. I've heard the last few days America's been trying to achieve herd immunity. I haven't heard this, but America has a very unusual strategy, and I don't know what they're up to. It's interesting in that perspective though, because America's health policy is going to have huge effect for the rest of the world. Things have been hectic. I'm actually in the middle of moving house. Lucy isn't able to make it tonight. She's in Queensland for a family event, unfortunately, and can't make it. And I'm very tired. I've been moving since last week, just after the live stream. So I started moving on Wednesday last week, and I've got one more week. Hopefully I'll be finished by the time this live stream rolls around next week. From the bath. Okay, so you can't see the high tide being emptied. You can't see the high tide on the bathtub from the moon, but you can see it from being filled and emptied. I was putting a glass of water from the books talk about moon affecting water in our body. Yeah, so yeah. With respect to tides affecting each other, I would highly recommend getting a program called Universe Sandbox. And this allows you to play with heavenly bodies. It allows you to just put massive objects into space and see how they interact with each other. You can do fun things like replace the moon with a black hole and see what that would do to our solar system. Turn the Earth into the size of a golf ball, turn the Earth into the size of a sun, and you can just play around this way. And that gives you a pretty good indication of how mass creates gravity and how it bends space-time. I played Universe Sandbox since the very, very first time it came out, and I've had such a great time with it. Now, during my downtime, I've been playing lots of video games this week. I've been playing Astroneer, which is why I'm on the space bent. It's a fantastic game. I've been thoroughly enjoying it. Now I'm just bring it up. Okay. Please chuck any any space or science questions you have in there, and I'll do my best to answer them. So Dr. Carl's also doing a question and answer very soon. I'd highly recommend getting and checking him out. I've done some Q&A with Dr. Carl before, and it's really fun. I'm really interested to hear what questions you guys are keen on. He talks about difference between dark energy and dark matter. I didn't have a chance to read the story, but from my understanding, dark matter is basically anything that's not a sun that we can't see. So with dark matter, it's basically like a rogue planet from my understanding, and I could be completely wrong. A rogue planet could be considered dark matter, and it's stuff that we can't see but makes up most of the matter in the universe. So it's not stars and stuff like that. Now, dark energy is actually completely different. So dark matter and dark energy, from my understanding, don't have anything to do with each other. In fact, they could be considered the opposites of each other, because dark matter actually creates mass. So when we're doing our calculations about where's the mass in the universe, we can look around and see the stars. We can do calculations to work out the mass, and there's a lot of missing mass, and it's thought that the dark matter accounts for that. That's from my understanding. I could be completely wrong on that. Now, dark energy is actually the opposite of gravity, from my understanding. It's what pushes the universe apart. So we can think about gravity as pulling massive things together. From my understanding, dark energy is something that pushes things apart and is responsible for the expansion of the universe. Now, I could be completely wrong on those things. You actually sent me an article, Stephen, and I didn't have a chance to read it because I've been flat out the past week. But from my understanding, that is a very, very condensed version of what those two things are. Now, have you ever looked into the thought experiment of Rocco's basilisk, Eden? Yeah, so I think about Rocco's basilisk as kind of a transhumanist Pascal's wager. So for those of you who don't know about Pascal's wager, it was basically a quadrant of options where Pascal, a very famous mathematician, basically put forward this gamble that said, you know, there's no benefit, there's nothing that can go poorly if you believe in God, because if you spread it out and you say, okay, I believe in a God and there's a God, I go to heaven. I believe in a God and there's no God, nothing bad happens to me, I just die. If I don't believe in God and there's no God, nothing bad happens to me. But if I don't believe in God and there is a God, I go to hell for all of eternity. So he basically sets up this Punnett square, this four-way square of one good outcome, two neutral outcomes, and one terrible outcome. But basically, he makes this argument that if you believe in the belief in God ultimately will pay off, because the penalty for not believing in God, if there is one, is so huge. But what Pascal's wager fails to take into account is a whole bunch of things. One of which being, if I believe in what about if there's a God that rewards critical thinking? Well, in that scenario, by you believing in God, it doesn't actually, you end up in eternity will end up in hell for all of eternity. Now, with Rocco's basilisk, it basically replaces God with a sentient AI. If you help that AI come into existence, it will create a world for you after you're dead, which is eternal paradise. And if you don't help it come into existence, he'll revivify you and chuck you into a cyber hell for all of eternity. It's basically exactly the same thing. And basically it's going to go through all these chat logs and all these videos since the internet has been created and work out whether you tried to help them. So I 100% support the creation of the AI. Devin's just brought this up. The theory of the scale of the universe constantly changing causes everything to appear spread out. There's actually some research that's been done, and I had a lecture in my astrobiology class about this, that a lot of the laws of physics may not actually be constant, and that as you move towards the edge of the universe, that the scale of the laws of physics changes. So basically the theory is that when the universe came into existence, you had a singularity. So you have this point where everything is condensed in an infinitely dense point, and maybe there was stuff before, but you can never go there because the laws of physics and time starts at that point. But then after that, it said the laws of physics change as the universe expands. So where we are, all the laws of the universe are constant. But if we look to the furthest reaches of the universe, they might look constant to us, but they don't actually explain the way that things work properly. Because these are just models that we map onto observations we have. They're not immutable, because they don't even exist. They're just an explanation. So all of science is built up on theories. So when we look at the edge of the universe, we try and map we might be able to explain like a lot of the way that things behave, but if those laws were different, it might actually explain it better, but it wouldn't explain it here. So it's difficult because we hold on to a paradigm, a way of viewing the world, which is that there are things like the speed of light, which are immutable. We say that they can't ever change. So when we look towards the edge of the universe, if one of the best ways to explain the data is to actually say that the laws of physics are slightly different. And I have just received probably the best gift ever. Thank you very much.
I'm making soup.
Oh, thank you very much. My dinner is coming early this week because of our move. Okay, so Stephen said that Sabine Hossenfelder said the same thing about dark matter and dark energy. It's interesting how the topic of God religion comes up so often when we talk about space. One of my grade 7s asked about essentially how can we as scientists can reconcile religion with our scientific understanding of creation. So there's a few different arguments about this, and obviously, you can believe in both, and you can't believe on both, depending on what you believe. So a lot of scientific Christians have talked about the 7-day model and this like finite amount of time that the universe has been created. Now these came out of Sumerian and Babylonian myths that fused together. And like I think a lot of this has some of these myths, like the flood myth, is probably going to be talking about the end of the last ice age. And Aboriginal Australians have flood myths where they're actually talking about the creation of the Great Barrier Reef, and that's been passed down. So big cataclysmic events like this have some bearing. Now with the creation stories, I think that they were created. I don't think they were divine, but there is something about space that is divine, and. How do we reconcile this? Okay, so we can say that God created the Big Bang. That's one of the easiest ways that we can say that. Another way is we can say that the scales of time in the Bible are actually different. So when we talk about a day is a rotation of the Earth. So we can have a bit of artistic license where we're talking about, well, if the Earth didn't turn for a number of days while a creator was making it, then that process could have actually taken, billions of years. Or it could be talking about epochs rather than a day. So, we could say that each of the ages, maybe the age of the dinosaurs was like a day. So there's different ways that you can spin this. Now, the reason, when we're talking about space, we immediately start talking about the biggest topics, like, are we alone? Where did we all come from? That's the first questions that come out. They're the questions that religion and science both try and answer. Now, one of the questions about reconciling religion with science is about asking, what does a creator or what does a deity actually do? So is there, Stephen Hawking has a number of different types of gods that can exist. So one of them is a blind watchmaker. So they basically set the laws of the universe going, and then they created the Big Bang, and then they just sat down and watched it play out. There's another god called the God of the Gaps, where a deity goes and does all of these things that are just outside of. Please just put it down here.
Spill it.
Well, please just put it up over there. Where the creator kind of is doing things just outside the realms of science again and again. So maybe he's like, just smaller than where the particle accelerator at CERN can look, the Great Hadron Collider. And then maybe he's like, just smaller than those particles there, somewhere between there and the Planck length. That's where the God exists. I would be very interested to hear about what the guy from the Ken Ham Museum, which is a very famous creationist museum overseas in America. George was a Belgian priest that came up with the Big Bang Theory. Yeah, so the church actually sponsors a lot of creationist research. One of those is actually the Vatican, I believe, was sponsoring Stephen Hawking when he was a postgrad to come up with a no bounds theory that actually would have no God in it. So religion is very, very interested in these types of ideas, and they fund it. They fund a lot of the research. Governments don't give a fuck where we came from. So it kind of falls upon religion to fund and answer those questions. Okay, so cryo-electron microscopy. I've actually been invited. I've given a lecture at a university which was doing cryo-electron microscopy. Now, there's been some images bouncing around about the most accurate image of a cell. but it's not actually a direct cryo-electron microscopy image. It's actually a recreation. And I've been arguing with a lot of people about whether it's an actual cell or not. It's not. What they've done is they've basically gone through and they've used it on a lot of proteins, which is super interesting because proteins are very, very small. We can't look at them using microscopes or electron microscopes. We generally look at them using particle accelerators. And now we have these cryo-electron microscopes. I haven't actually seen this, the images, but yeah, I always so one really interesting thing about lecturing and like I guess doing a question and answer thing like this is what happens if someone asks you a question you don't know the answer to, like when I started lecturing at university, and tutoring is even worse. A lot of the kids are smarter than you, or they're more up to date with the latest information. How do you navigate that? It's really scary. Like, what if you're in a lecture about a topic and some kid in the audience knows more than you? I know I've been in a lecture where I've known more about the lecturer on certain topics, and I've asked them a question because I was genuinely interested in the answer, and they weren't able to tell me the answer. And the trick is you deflect, or you can throw the question back. So, for example, if the children ask you, like, how can we have a God when we have all this creation science? And you can throw it back and say to kids, what do we know? What don't we know? Where does a God fit in? Are gods and science compatible? Get a discussion going, because there's a very good chance God still exists. Like, one of the really interesting things I discovered, we've talked about this a bit before in the Fermi paradox and the Drake equation, right? Life should be everywhere, right? Life should be everywhere in the universe. If we look at how many planets are out there capable of supporting life as we know it, there should be life everywhere. Where is it? That's the Fermi paradox. So the life should be everywhere is the Drake equation. The Fermi paradox is like, well, if it's everywhere, why isn't it there? One of the answers to the Fermi paradox is that there is a God, and he created life only on Earth. And that is a really interesting one, because if life is so common, the longer we go looking for it and don't find it, the more likely there is that our universe was created by an intelligent creator. So basically, there either is life in the universe outside of Earth, or there's not. And either answer to that question will radically change the whole of the human race. Because if there is, it means that life is everywhere, and it means that we're not alone. Incredible. And if there isn't, it means we are alone, and it means that there probably is a creator, because the statistical impossibility that we are alone is so... It's a number more amazing than I can think of. Basically, everything says that there should be life out there. If there's not, the only answer to saying that improbable is that there will be a God, basically, or we're the first. So one really interesting thing that happened to me, I got to meet Jill Tarter, who was the first female president of Seti. So Seti is the search for extraterrestrial intelligence. She was best friends with a guy named Carl Sagan. And while she was in charge of Seti, Carl Sagan wrote a book about her called Contact that was turned into a movie with Jodie Foster. And Jodie Foster, that character, is Jill Tarter. And I was lucky enough to meet Jill at the Astrobiology Conference in Australia, the first international astrobiology conference. And she was the keynote speaker. And someone in the audience asked her, oh yeah, dude, fuck. Like, I spoke to her heaps about like what it was like being friends with Carl Sagan, what it was like running Seti. That was fucking cool. Really interesting person. And she said, she still speaks now. She's got TED Talks and everything. Please go and check them out. Someone asked her one of the most interesting questions I've ever heard asked at any conference or anything in general. And they said, okay, once you switched it on and you didn't receive messages from aliens in like the first few months, it probably would have been pretty clear to you that it was very unlikely that you were going to receive anything, right? Either you switched it on and you were bombarded, or you switched it on and there was radio silence. Why did you bother keeping looking when it was pretty evident that it was very unlikely you were going to find anything? Like, why are we still doing it after 40 years, 50 years? And she answered that, and she said, it's like looking for a needle in a haystack. Well, you know what? Maybe it's not finding the needle that's important. Maybe the real thing is to ask the question. And this is what the religion and space we're doing this. She said, what if I could ask a question that was so big that it united the whole human race? What if we could ask, are we alone? And this question transcends wars, race, religion, culture. It's a question that every single human is curious about. And she said that finding extraterrestrial intelligence wasn't as important as the search, because the search is what brings us together and unifies us as a race. And this blew my mind. It completely changed the way I thought about pointless projects like Seti, but also changed the way that I thought about the whole human race and our culture in general. Like, why do we do things? Does it have to be a purpose? Do we even have to have any chance of finding it? Or is maybe just the process and asking the right questions the right way to go forward? Nothing ventured, nothing gained. Definitely. Do we? I might also just this week I'm probably going to cut the live stream short a little bit. I'm going to probably call it at about 8:30 because I am still moving house. I haven't got internet connected here, so we are just hotspotting from my phone. But next week we're going to have Lucy back, and we'll go back into that normal thing. And a big special shout out to Max if he's still there for last week. Okay. Do we want to talk about anything else? Oh, Dyson Sphere candidate system. Okay. So if anyone else has watched this, how do we look for aliens? Like what's the main method we use when we're looking for aliens? Now, there was a very famous satellite called Kepler. It was actually a space telescope, which is really cool because when everyone's complaining, oh, Elon Musk's putting satellites all the way across Earth. Who gives a fuck? The best telescopes sit in space because they've got no atmosphere, no light around them. Light pollution isn't getting them. They can just look straight out. So we put a little satellite in orbit with a telescope on it. We pointed it at the darkest point of sky to see what we could see. And Hubble did that actually. Hubble did it, and it went, and it was just filled with galaxies. So we knew the whole entire universe is filled with galaxies. Then we got Kepler to look at those stars. We got a patch of sky, and we just scanned it. And what we did was we looked at the light. So by looking at the light from a star, we can observe something which is called a transit event. A transit event is when a planet goes in front of the star and the light dims a little bit. So you see it fades out, especially if the planet is very similar in size. It it eclipses it. It eclipses it, and then the light drops right down. So that's one of the ways we look for planets. Now, there's some really unusual patterns of light. So sometimes you'll see really quickly like blip, 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 blip in the light coming out from a star system or from a star. And that's a eclipsing binary. So it's a star like a black hole or a star that it's not very bright going in front of the other star really fast because the binary stars orbit each other, right? You can have there was one though that we couldn't explain, and one of the scientists came up with a theory that it might have been a Dyson Sphere. Now I believe it's still a candidate for a Dyson Sphere, but they've said it's not super likely because there's a bunch of other things I would expect with the Dyson Sphere. But as far as I know, it hasn't been disproved, but I don't think they have a great explanation for it. I think they think it may be this thing called an accretion disk, which is when a star forms in the early stages of a solar system. Basically, the way that a star forms, right, you have a big nebula of gas. And in the center of that nebula, we talked about gravity before, things can start to pull each other together. And when they reach a critical mass, they can pull all that gas in. Now, if there is any rotation at all to that, angular momentum is conserved. So like when you sit on a chair and you spin around, when you pull in or go out, you speed up and slow down. but you're always spinning with the same amount of energy that you went in with, just losing energy to friction and things like that. So a giant nebula is also spinning very, very slowly. It condenses in, and that's what creates the initial direction of a solar system. When it does that, the gases start pulling in tighter and tighter and tighter, which eventually will catalyze in fission, which will get the sun started, and all the other debris will sit in the flat plane. There's some experiments I could do that would really show this super well, but basically it looks like Saturn, because Saturn is a miniature version of exactly the same thing. In fact, Saturn's rings are basically an accretionary disk around a protostar, which is basically like an early version of what our solar system would have looked like. Now, I can talk for ages about that because it's super interesting, but I'll talk a little bit more about this. So an accretionary disk will create basically bubbles and lumps and things like this. So the light will be dimming and shining at different amounts. And that could look like a Dyson Sphere. In fact, a Dyson Sphere and an accretionary disk share a lot in common. Is that what the galaxy is doing on a super huge scale? It is. So there's the Emerald Tablet, which was by the earliest scientific work. I'll just read you a translation of it. The Emerald Tablet was created, and it basically says something like this, right? So this is the earliest scientific work that we have, which is from Egypt, I believe. I'll see if I can find you a early modern versions of it. That which is below is like that which is above, and that which is above is like that which is below. To do the miracle of one only thing, and as all things have been and arose from one by the meditation of one, so all things have their birth from this one thing by adaptation. Now, basically, as above, so below, as so below, as above. And this is I love this idea, because it's basically saying that we can see in Saturn the solar system, and the solar system we can see the galaxy, and vice versa, all the way back down. So with this same like memes or ideas repeated up and down, everything is fractals, damn straight. So I'm just going to jump in super quickly before this question goes away. Do you think it's possible that in the higher dimensions there may be more space than in our 3 dimensions? Oh, definitely. Most life forms live in higher dimensions, similar to subspace and Star Trek. Yep. So I have a fantastic thought experiment to show you that higher dimensions have more space. Okay. Say, for example, I have a 2-dimensional briefcase, basically like a normal briefcase, right? Now, I have a 1 meter by 1 meter squared briefcase. Is that right? Let me think about this for 1 second. Yes, that's true. A 1 meter squared 2-dimensional briefcase. We can basically think as a briefcase as being 2-dimensional. What is the biggest walking stick I can fit in that briefcase? If someone wants to put that down, there's a 2-dimensional briefcase, but we're going to say it's a normal briefcase. For all intents and purposes, a briefcase is basically 2 dimensions. What is the biggest object I can fit in a 1 square meter, a biggest walking stick I can fit in a 1 square meter briefcase? 1 by 1. Anyone want to hazard a guess? You can work it out using Pythagoras' theorem. I'm going to give you a 15-second counter. Try and guess what it is. Dun, 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 dun. Bingo, square root of 2, 1.4. Yep, so the square root of 2 is the diagonal in a 1 square meter briefcase. Now, this is actually very convenient for us, because if we say that this briefcase is root 2 in a 2-dimensional briefcase, what's the biggest walking stick we could fit in a 3-dimensional 1 cubic meter briefcase? When you work this out, this is going to blow your mind. So 2-dimensional briefcase? Oh, thank you very much. Unfortunately this week I'm moving house, so there's going to be a bit of a lag. Please, if you want to chuck in the answer to this. So in a 2-dimensional briefcase, with 1 square meter, we can fit a root 2 object. What about in a 3-dimensional briefcase? A 1 meter cube briefcase? What is the longest rod we can fit in there? The longest walking stick in 3 dimensions? See if we can guess. I'm going to give it a few more seconds and then a few more. So 2-dimensional briefcase, 1 meter by 1 meter by 1 meter by 1 meter. Root 2 is the diagonal in that. What's the diagonal in a 3-dimensional cube? The answer? I'll just double check that no one's put it through yet. Let's have a look. Okay, the answer... The answer is root 3. So I'm not actually sure what root 3 is. But it shows that in bigger briefcase, in higher dimensions, we can just keep on extending that link. So in a 4-dimensional briefcase, in a hypercube briefcase, and the hypercube has all 1 meter edges, the biggest Mary Poppins walking stick that you can fit is root 4. It's actually 2 meters. It's the biggest walking stick. That's exactly right. Square root of 3. So in a 3-dimensional briefcase, roughly something about the size of a pallet, an IBC, intermediate bulk container, you can fit square root of 3. In a 4-dimensional briefcase, TARDIS type thing, you know, but 4 spatial dimensions, you can fit root 2. Root 4. So you can fit a 2 meter walking stick in a 1 meter. It's not a cube though, it's a hypercube. That's the longest bit. So basically a hypercube is where each one of the faces of a cube is also a cube. It's hard for our brains to comprehend this because we can't exist in 4 spatial dimensions. So we generally express it as the 4th dimension as time, where it moves, but in 4 spatial dimensions, it doesn't actually move. So could higher beings exist in 4 spatial dimensions? Yes, they could. I don't know how, as far as I know, there's around 36 spatial dimensions that exist in our universe, but most of them are kind of like the NPC dimensions. You know, where basically they're just folded in on themselves. They fulfilled some law of physics, and we don't interact with them anymore. They just float around somewhere. But maybe they're important. I don't know. I read Stephen Hawking. He said, "Don't worry about them, bro." But yes, there could be organisms that exist outside our time dimension as well, and that's another one where things get interesting. There's also a very interesting book by Greg Egan called Quarantine. If you're interested in aliens and beings and quantum physics and all that stuff, like go read that book. He explores it to the nth degree and past there. Highly recommended. Now, a lot of people have issues with Elon. I actually think Elon is a product of America, and there's not much you can really do. That America will always produce an Elon. The other thing I wanted to talk briefly about, a lot of people have been upset about people trying to colonize Mars, saying that we should fix Earth first. And I actually really don't believe this. I think that learning to terraform Venus and Mars is the best thing we can do as a human race, because we have practice planets that we can go and try and do stuff on before we try things out here. So, you know, Bill Gates, who's just announced that he's divorcing, he and Melinda Gates are divorcing, was a big proponent. Bill and Melinda Gates were talking about modifying the atmosphere by putting particles in there that reflect light back into space. Now, we don't know what that would do, what the consequences could be. But we actually have other planets we could try that on. Like Venus has a runaway greenhouse effect. We could definitely try and do that there and see whether any bad consequences happen in ways that we didn't predict. And nothing dies if we fuck that up. And yeah, like, you know, a lot of people say, well, you know, we terraform Mars at the cost of Earth, and that's actually a logical fallacy. Like people will say like, oh, we shouldn't give money to old people or people in the dole because or give foreign aid because we should be giving it to people here. But those two things don't necessarily cancel each other out. This is a really common mistake you see where people say like, I forget the name of the logical fallacy, but it's basically like, well, if this, then that, or if this, not that, and it makes no sense. Oh yeah, and Emily just started a group where we make plans to terraform Venus. I'm hugely in favor of this. NASA has been in the past, they've actually commissioned people to design a cloud city, and there are plans for us to live in one of the bands of false dichotomy. That's right, Stephen. The Earth might cull us. If we fail at Earth, we are stuffed. We've got all our eggs in one basket. There are people living in space permanently right now, but there's only one little bit that needs Earth to sustain it, which is the International Space Station. Soon, though, we will have... the Russians and the Chinese are building their own space station. So the Russians will be sending cosmonauts, and I learned a new word this week, which is a taikonaut, which is a Chinese spacefaring citizen. Yeah, so we can do a whole bunch of stuff, and the best thing we can do at the moment is monetize it, make it appealing for business, because that seems to solve problems really, really well. So if you want to go to Venus or Mars, we have to work out a way to get everyone to want to spend money to do it. So that might be getting $1 trillion, multi-trillion dollar asteroids and bringing them to Earth. It might be sending one of the most popular ideas I've seen that was a really great one was to send a reality TV show like Big Brother to Mars. One of the cool things that SpaceX has done, and Colonel Chris Hadfield did this a lot too, is make space exciting again. Like, we've been following rocket launches and touchdowns, splashdowns in the ocean recently. These things are being televised and people are getting excited about them again. But they've been happening since we landed on the moon. Like we've maintained a presence in space this entire time. Meow and the ISS have been in space with people living on them since the early 90s. And like, those people need food, so we have to fire rockets up all the time, like weekly, like monthly at the very least, to resupply. So it's really good that all of a sudden people are getting interested in space again. I don't know why it didn't stop. Like, if people getting murdered in shootouts in America can still make the news, even though it happens every week, why can't space be exciting every week? Like, I just actually don't get it. 60s sci-fi fashion and architecture, so that's retro futurism. There's also a brand of 80s sci-fi fashion and architecture called cassette futurism, which there's a group on Facebook. I highly recommend it. Space is always cool. It can't go out of fashion. It's literally, we're on a rock flying through it. It's never going anywhere. Also, I have a weird little vignette that I don't know why that's happening every time I bounce. Okay, I'm gonna almost call it. I might just take one or two more questions if anyone has them, and then I'm gonna sign off for the night because I have to finish moving. Next week, Lucy will be back. I tried my best to get on and get some stuff happening this week. It's actually really difficult to do this on my own. I was hoping PPT, Patrick Palmer Thomas, that way, would join me tonight. Last minute, I forgot Lucy wasn't on. I've been moving, it totally slipped my mind. I was hoping maybe we can get PPT in again for a talk. Do we know much about the Russian COVID vaccine? I've heard mixed things about the Sputnik vaccine. I haven't seen enough data. The Sinovac's the same. Mars argument, positive consequences heading to Mars. Oh, I'm getting lots of messages. Cats on synths in space, a similar theme. Cats on synths, picking up a vibration noise. Yeah, I haven't got any microphone. I haven't got any. I was trying to get this awesome camcorder set up as my little thing for tonight. It didn't work. I might try again next week. I got it recording video. I picked this up for free. This is so cool. Like, I love I love like old school obsolete technology, like an unhealthy amount. Yeah, so hopefully we can get more ordinary people in space. Oh, it's my fan has started. My computer's overheating. I'm just gonna, before I go, I just want to show you something really cool, which is this like pops out and it has like a fucking cassette tape in it. Look at this. What the fuck? Pops out and it records on here. This is crazy. This is cellulose tape, and somehow there is a little thing in there. See that drum? That bloody silver drum, right? That is a magnet that somehow, I have no idea how this works. Light comes in here, somewhere gets turned into magnetic waves that then get put on mashed up leaves with, I'm guessing, magnetic nanoparticles or some shit on it, and then you can reverse it. You can use this exact same thing to read it back. What the fuck? It makes no sense. How is this the first way that we recorded video? I am blown away. I'm also very into film photography. I've been taking black and white photos, and I've actually just joined Roselle Darkroom. I will be doing some streams on that, and one of the things I was going to do today, but I didn't actually have it ready in time, was I wanted to do some photography development on here. Next week I'll see if I can do it. I'm going to be developing black and white film using caffeine, vitamin C and washing soda, and then I will be making prints using I'll be using cyanotype chemicals to develop them here. So without a darkroom, I'm hopefully going to do every single thing that I need. All the chemicals can pretty much be bought on eBay or Bunnings. Should be really exciting. It's going to be wizardry. I'm going to see if I can get it done. I might have to do some recordings. If I do, I'm going to use this, and then I'll put them on the computer. And we can watch how it's done. If I can do this all the way through, it's going to be probably the most lo-fi end-to-end photography that's ever been done, maybe in the world. I'm going to make that claim. Okay, so basically we're going to do black and white film photography. We are going to develop it using over-the-counter chemicals without a darkroom. I'm just going to do it inside a bag, hopefully. And then I'm going to take those negatives and then I'm going to put them onto some photo paper that I'm going to make outside of a darkroom. I'm going to use UV, and then I'll wash it away, and I should end up with a photo. Fingers crossed. Stay tuned next week. If it works, I'm going to write up a protocol and give it to you all. Thank you very much, everyone, for bearing with me. I'm so sorry it was just me this week. Hope it blew your little minds with space talk and conversations. Best of luck to Devin getting his Moderna. Hope you don't get too many side effects. I'm going to do some reading about Moderna and give you an update next week. And thank you guys all for tuning in. And we're going to call it a night. Thank you for tuning in for the little hour that we had. And love you all. Can't wait to see you again. This is Meow signing out. Thanks very much, guys.